Hello all, welcome back. Today we are going to see about the VertiPaq, whatever the stuff we discussed previously, that is nothing but X velocity and analytics engine. This is nothing but it uses a storage method called VertiPaq. Okay, VertiPaq storage. So the simple example I can give you the VertiPaq storage is, it is a kind of the column store index that we have. Okay, it's nothing but the column store index, not an example. It's like just the one feature that is a major feature is column store index. So in the VertiPaqs, whenever you create a table or whenever you create a data anything, so generally the columns are stored as objects rather than the rows. Okay, so like let's take you have a table where you have a table as columns C1, C2, C3. In the general scenario, how the data will be stored? Okay, C1, C2, C3 for the row 1 data, row 2 data, row 3 data. Okay, but now it will be not stored as a it will be not stored as a rows. Okay, it will be stored as a separate objects. C1 will be stored as a separate object, C2 is separate, and C3 is a separate. So generally here the columns are stored as objects, individual objects. Okay, so because it is being stored as individual objects, the performance whenever you try to retrieve the data, or whenever you write a queries against it, the retrieval will faster, and because of this the compression is also very far. Like if it uses the compression method where the data uses less space. We are going to see how the data is being stored, that all in few minutes. And the one more thing you have to remember is that if you write any calculated columns, okay, if you write any calculated columns, then what you can write as usual. Okay, columns, the one thing is that it acts same as a normal columns. Okay, it acts same as a normal column, but uh, the compression might not happen, might happen. It is not, it depends on the way you have created the calculated columns. Okay, it acts as a normal columns, but the disadvantage is like if it is you might be using some complex calculations, like looking up with some data, if this that then do this, if this that you have written many case statements in the calculated column, then the compression might not happen on that column. Because of that, since there is no compression, the size will be increased. Okay, no compression, large size. No compress, more size. Okay, so larger size, that will happen here. And so if you want to create any calculated or most complex columns, better I suggest, when you pull the data from the source, try to create at the source level. Try maximum, if whatever the calculated columns you want to create here, try maximum to create at the source level, so that it will be easy for you. And the compression process which we use, that might happen on the existing column, but when you create a calculated column, there may be a chance it might not be compressed properly. Okay, so that might get reduced because of the calculated columns. Okay, so just if you can do the calculations at the source level, just try to do it and get it from the source itself. That's the best thing to do that. And the same thing, if you want to provide any hierarchies, yes, you can create hierarchies to here, and you can also create partitions on it. The same, whatever you want, you can create a partitions. And here also you can create a referential integrity. So referential integrity means you can relate the tables, because when columns are stored as individual objects, but when it is stored as a table, yes, you can provide a differential. But people might be thinking, because now the columns are stored as objects, whether we can create a differential integrity or not. Yes, we can create the differential integrity. And whatever we want we can do it. Like most of the features that we have in the SSIS, the same features can be applicable here too. At the same time, here the data, whatever the data you store, the data is stored as segments. Okay, the data is stored as a segment, so that and at the same time the data is compressed here. The data is compressed. We are going to see the how the data is being compressed. Okay, let's take you have, that is a major part in the tabular model. So let's take, I have a column called customer, and I have a column called salary, or I can say sales, or I can say customer sales for each customer. This is a, I have a table called sales, and the table has a customer column and the sales column, sales amount. Then what we will be, okay, customer is a customer, I can say anything, Walmart, and Costco, and I might have some customer one. I might have the same customer multiple times, because there may be multiple transaction, right? Customer sales ID, I'll have the sales ID here, I'll have the customer, and I'll have the sales amount. Sales ID is 1 2 3 4 5 6 is a Walmart. It has 1.5, 3.0, 4.5, 1.0, or I can say, yeah, 1.0, I can say 4.0, okay, 2.0, something like that. Okay, so generally how the data is being stored is, for the customer, right, it will take the uniqueness of all the records. It will take, okay, Walmart, and it will take the Costco, it will take the customer one. It will assign the IDs to it, that integer value. So the backend, the data, instead of this, the data will be stored as 1 2 3. Walmart is 1, Costco is 2 3, 2 2 and 1. This is where all the data is stored. And if you remember in the T-SQL videos or somewhere where I covered, like if you have or it's a general concept. So whenever you store the data in the characters, it takes more space. Whenever you store the data in integer, it takes less space. So this is a technology that you add for the VertiPaq, okay, storage model. So they'll convert the data into the integer format and they do it. And if the sales amount, first thing, the best thing to do is that convert it into the currency. Okay, when you convert this sales amount into the currency format, even it is in a decimal format. Okay, whenever you have in the decimal format, the storage will be stored in a different way. But if you convert that into the currency format, okay, then that will that will be like, it will be faster. It will take less space for storing the data. Sometimes the system automatically converts it by multiplying with some decimals into the integer. It will multiply it with 10 to have it as 15, 30, 45, 10, 40, 20. So now the decimals got converted into the integer. So they will store the values as integer. When you are retrying the data, you will convert back into the original value, and then it will display. You can see that original value. Okay, this is the other way of storing the data for the decimals. But when you have the decimals, I prefer rather to use a currency data type, so that it will be easy and it will take less space for you. And the data is always being stored in two ways. Like whenever you have the data, right? So it's the encoding is done in two ways. So the column, and I can say it's a data encoding or column encoding. Always encoding types, there are two types you have in the encoding. First is a value. The value is nothing but whenever you have the decimals, or whenever you have the decimals, it will try to convert the integers. Like as I said, 1.5, 2.5, 4.5, 4.0, 1.0. How the system does conversion to the integer, it will multiply by 10, and it uses the best way. This is only one example. It uses the best way, and the final value will be stored as an integer. So the storage that you require for storing the integer to the decimals needs more space compared to the integer. So it will be stored as an integer, and when you it will be multiplied by 10 to get the integer value. and whenever you return back, that will be again divided by 10 and you'll get the value as 1.5, 2.5 as output. Okay, so that's a value. And you also have the hash key encoding type. So what it does is, let's say you got the customer name, customer 1, customer 2, so on, like that. What is it creates a ASCII like unique integer on the number. So generally if you have anything like this after take you using some algorithm, it will convert the customer 1 to some integer 1 to 3, and customer 2 it might convert into the 1 to 4, something like that. And whenever you get the customer 1, at the back end the data will be stored as 1 to 3, not as a customer 1. That itself reduces, and this ASCII will be performing mostly on the text fields, and these values you will be performing on the decimals. Okay, this is a way how the encoding data is being stored. And it's better like whenever you pull the data from the source, like we generally do in the data modeling concept, where in the OLTP, when you build a data model or like OLTP relational data warehouse, generally what we do is that, okay, in the source you might have the table called customer. So I'll explain in the new window. So you might have the table called customer. So customer might be having the customer ID. I'll just go with the 2 columns, and customer name. So the customer ID might be customer 1, or it might be a different. So basically there might be scenarios where the customer ID might be named as CUST1, CUST2, something like that. And here the customer might be a Walmart, and it might be Costco. So when you get it into the relational data warehouse, like relational OLAP, so generally the same structure might be converted into dim customer with key. Okay, with as a customer key, and you might be calling this customer ID as xref. So many people use that different formats. You can call as xref customer ID. Then you can have the customer name as same, customer name. So customer ID 1, 2, and xref will be cust1, cust2, Walmart, and writing shortcuts. Okay, like my handwriting is worse, so please forgive me for that. Now here in the normal scenario, wherever whoever wants to use the customer ID, they will be using this. Nothing but it's a varchar. But in the relational OLAP, the customer key, whoever wants to use the customer ID, they can use the customer key. So it is an integer. So storing the integer value is like it occupies less space. It's a kind of the same. Okay, here also it follows the same way. Converting the values, they'll be converted, but here the system automatically whichever it thinks best way to convert, and whichever it thinks like best like after conversion, or whatever the space it uses for the conversion for the converted value to store. So it system analyzes that first, and then based on that it does the conversion, it stores. Okay, this is a feature, it's a major feature in the tabular model, that is a VertiPaq storage model. Okay, storage method. These are things that it will follow. It will convert the existing data, like it will convert the values, and it will also convert as a, depends on the requirement, it will convert as a value, that is the encoding type, and it also converts the as for the text types. Okay, so we are good with this, and we are going to create a sample model in the next video, and then we will work on that. Thank you guys, see you, have a good day, we'll meet in the next video.